Let's see the question. What would be the interaction force between two copper spheres, each of mass 1 gram, separated by distance 1 meter, if the total electronic charge in them differed from the total charge of the nuclei by 1%? See, in the question, what we have is there are two spheres, and in these two spheres, what we can say that, let's check, we have, this is one sphere, this is another sphere, just roughly drawing. And the distance between them, you can take it to be small r, and the charges on each will be equal to q. So our job is to find out the force, is it not? So force is equal to straightforward 9 into 10 to the power 9 q into q, that is q square, divided by r square. R square is 1 square, they have given 1 meter. Just check the data. R is equal to 1 meter. But the main job here is to find out the charge. How do we find the charge here? Let's check how do we find the charge in this case. Just look at the language. If the electronic charge in them differed from the total charge of the nuclei by 1%, what does it mean? In general, number of electrons is equal to number of protons. Now, it can be that it has lost few electrons, and therefore the charge, the total charge of the electrons have changed. Now it is no more equal to the charge of the protons. Therefore, we can say that this particular sphere is charged. Is it not? Now, how much the charge is? The charge of the sphere can be, the charge of the sphere can be due to electrons that are lost. Due to electrons that are lost. Just look at the question. Now, how many electrons will it have? What's the mass they have given? Let me just see the question. The mass is 1 gram. Just look at the uh, language of the question. The mass is 1 gram. And in 1 gram, how many moles will be there? Let me just clarify. The number of moles of atoms, I'm talking about any one of the spheres. The number of moles of the atom will be how much? The number of, it will be mass by molecular. Number of moles will be mass. Mass is 1. And the molecular mass is how much? Molecular mass is, as far as I remember, it is 63.5. 63.5. Is it not? So mass is also in grams. Number of moles, I am taking mass by molecular weight. 63.5 or 63.54. If I am wrong, you can rectify it. This is the number of moles. So within the number of moles, how many number of atoms are there? So number of atoms of copper will be equal to each mole 1 by 63.54 moles into 6.023 10 to the power 23. This calculation. And now each, okay, that we will calculate it. If required, we will calculate it. Now each of them have, what is the number of protons present in the nucleus of each atom of copper. The copper's atomic number is 29, I suppose. So, assuming atomic number of copper is equal to 29. This I am mentioning in brackets. Huh? So number of copper atoms we already calculated in the previous step. That is, I did not calculate, I just mentioned it. Number of, and every copper atom has 29 protons, is it not? So number of protons in the sample. Number of protons in the sample is how much? 1 by 63.54 into 6.023 into 10 to the power 23, and each of them has 29 protons. So I multiply by 29. This is the number of protons in each sample. And if this is the number of protons in each sample, then what is the total nuclear charge? The total nucleus of, if we sum total, the total nuclear charge will be equal to, let's check. So the total nuclear charge, it will be equal to the total number of protons 1 by 63.54 into 6.023 10 to the power 23 into 29 multiplied by the charge of each proton is 1.602. You can treat it as 1.6 into 10 to the power minus 19. This is the total nuclear charge. And then what is the charge acquired? The charge acquired by each sphere. They have said that the sphere's electron charge and the charge of the nucleus, they differ by 1%, means one is the just 1% difference. That means 1% of this, 1% of this particular, how much? 6.023 10 to the power 23 divided by 63.54, this is 29, 1.602 into 10 to the power minus 19. What is this? This is nothing but, this is the charge Q. This charge we were thinking about. This charge we found out. This is the charge Q. So let's check. This charge Q, I am mentioning this as Q. Now again let us check. This charge, once we can calculate it, then the calculation shows the charge, please check the calculation, it is 4.298. You can take it to be 4.3 into 10 to the power 2 coulombs. Now once we know the charge, then the force will be equal to, as we were discussing, 9 into 10 to the power 9. The charge square 4.298 into 10 to the power 2. This whole square, is it not? Divided by distance square is 1 square. It is almost coming to be 1.74 into 10 to the power 15 Newton. So the two spheres will be interacting with this much force.